Welcome to today's movie. In today's movie, we will look at the two-sample t-test for dependent samples, and we will use Excel to solve the problem. So what we want to do is construct an hypothesis test, but we'll also look at the use of the confidence interval to undertake an hypothesis test as well. So in a later movie, we'll use SPSS to solve exactly the same problem. So if we go to Excel, you will see that we have a series of people, and we have 45 students who have completed an assessment, and you can see the score for the assessment in those cells. They then receive extra help and repeat the assessment, and you can see the U score. So you can see that for each person, the first variable x1 and the second variable x2 are related because they are measuring the same person. Then we repeat the exercise for person 2, and we have 45 people or students in this particular data collection. So what we want to do is we want to see whether or not there is a difference in the population scores between each person. So is the mean value of the difference between those scores for all different scores, for all different people within that sample, is that 0? And the null hypothesis is that there's no difference between the scores. The alternative hypothesis that we're going to take is that there is a difference within the scores. So because we're talking about a difference there, we have a two-tailed test. Now we're told in the question in the book, because this problem comes from the book, that the populations are normally distributed. If you're not told that, then you could always do a quick check to see whether or not it's likely that the data is normally distributed. Because the data is population normally distributed, we do a two-sample paired t-test. Now what I've done there is, as you can see, is there's the equation, the t equation for a paired t-test, and there's the standard deviation and the degrees of freedom. So these are the equations that we use, as you can see there. Okay, using Excel. Now, when you use SPSS, it's a lot simpler, a lot easier to do, as you'll see in a later movie. So if I calculate the mean average support after they've got the extra support, then you'll see that that's given by average C5 to C49. And that comes out as 56, nearly 57. And if you do the mean value before the support, then that comes out to be 53. So you can see there is a difference between the two. The question is that statistically significant? So we have step 1 is state the hypothesis test. Step 2 is say what the test is. Step 3 is to decide what your level of significance is. So we're going to take 5% as normal. All we're looking for is that there's a difference between the two scores. So capital D is 0. N is the count. So remember, if you look at the equations, you'll see we need n, which is the total number of numbers. So we use the Excel function count. We need to know the sum of the differences, and we need to know the sum of the differences minus the difference mean squared, as you can see there. Okay. Then we can calculate the mean paired difference, d bar, and we can also calculate the standard deviation, etc. Okay, so you can see then that the standard deviation is 15.29, the mean paired difference is 4.07, the sum of the difference minus the average difference all squared is 10288.72, and so on. Okay, we can then substitute the numbers in to get the t-cal value is 1.7874, or let's say 1.79 to 2 decimal places. Well, that's quite high, so it's a possibility that this difference between that and that could be significant, But statistically, the only way to tell is to actually calculate the critical values. So to calculate the critical values, we need to know the degrees of freedom, which is given by this equation, as you can see there. And that comes out to be 44. We can then calculate a two-tailed p-value using the Excel function t.dis.2t, and that comes out to be 0.08. Now remember, this is two-tail. We choose a significance level of 5%, which is 0.05. Our two-tailed p-value based upon the sample data comes out to be 0.08. That is just bigger than that, so therefore we say we can accept the null hypothesis, and the null hypothesis says that there's no difference in the mean difference between the scores. Okay, so we accept the null hypothesis that there's no difference in scores. Okay, now you could, like before, calculate using the t.inv.2t Excel function the critical values of t. So if you do that, the upper t critical is 2.02 and the lower is minus. Now that should say minus. Okay, so that should say minus. Remember, it's plus and minus. Okay, right, and we can see there that that value lies between that value and that value. So again, you would accept the null hypothesis being true. Okay, the alternative, of course, is to do a confidence interval, etc. So if you rearrange this equation for D, then you can show, if you look here, look, that you know D is 0, L is 45, you know what the mean differences are, so you can substitute all the values in and you find that the lower critical confidence interval for the difference, D minus D bar, is minus 0.5196, and the upper confidence interval for the difference, which is equal to D minus D bar, so that should be plus there, not minus. My apologies for these small errors. So I'll just change that for you. Okay, comes out to be 8.668, etc. Okay, so, and you can see, because our value lies within that region there, then we accept the null hypothesis being true. So you can see there's our mean difference value, and that lies between that and that value. So the null hypothesis is accepted. So the evidence suggests that there's no difference between the population differences within this based upon this sample data set. Now obviously you could use data analysis. So in this particular case you can see that I've given the data analysis solutions there. So you want to click on data. You want to click on data analysis. There we are. And then you want to scroll down and you can see there that you've got t-test paired to sample for means, and that's the one you want. Okay, you know your variable range is C4 to C9. The variable 2 range is D4 to D9. Your hypothesized mean difference, which is D is equal to 0, is 0. Because I've gone to row 4 there, that's the label, remember. Okay, my alpha is my significance level is 0.05, and my output range is in cell G4, which is there. Okay, so when you click OK, you'll get these results here. And as you can see, if I do a screenshot, you'll be able to see that they're exactly the same numbers as what we had before. So I'll just do a screenshot. Give me 1 second. Okay, let's go back now to that and paste it in there and scroll up. So first of all, you can see that we've got, it gives us the mean values. You can see, look, 56.99 there is the same as that. 52.91 is the same as that. And you can see then the differences. So the observations are 45. So you can see there N is 45. And if you keep going down, the degrees of freedom are 44. Well, there's 44. The t-statistic, t-stat is 1.78. And as you can see there, 1.78. So you can see all the numbers are actually the same. Notice please that it gives you a 1 and a 1 and a 2 tail p-value, please note, and it also gives you a 1 tail upper and a 2 tail upper critical T value as well. So if you look here, you can see, look, there's a p-value 1 tail. We take the 2 tail, which is 0.08, which is the same as that number, and there's your T value. So remember, it's plus or minus 2.015, which is the same as those two numbers there. Okay, so that's how you perform a 2-tail paired t-test. Keep well, everyone. In the next movie, we will look at solving this problem using SPSS. Bye for now.